Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this problem of GFG. So let's move on to the problem guys. So here we are given with two binary trees and our task is to check whether each level of the tree are anagrams of each other or not. Now what are anagrams? Suppose uh, two array or string are called anagrams. Suppose this is a array, this array A1, this array A2. These two are called anagram when they both contain same value, like array 1, 1, 2, 2, 1, suppose 1, 3, 2, 2, 1, 3, these are both same. The order of number are not same, but it contain 1, 3, 2, it also contain 1, 3, 2. Okay, so the number are same in A1 and A2. String A, B, U Z C is equal to Z C U A B A. These both are same. Order are not equal. That means the number A B U Z C occurring in this number and exactly both are same. Okay, you can see after sorting both look same. Okay guys, so now how we will gonna to check it now. So first of all, for each level what we can do, we have to check level wise. So what we can do for level wise, we can do bfs, like first of all we will handle for level 0, then for level 1, for level 2, one by one for each level, and afterward when all level complete then we can return our answer. Okay, but now suppose we are at level 1 currently. So this vector, suppose there are some value this, there are some value this is of tree R2, this is of tree R1. Now, how can we say these both are anagrams of each other? So guys, what we can do, suppose here a value A, suppose a value A exists in in R1 and R2 tree both. Now suppose in R1 A exists X time, in R2 suppose A exists any value A. Suppose A can be any 2, 3, 5, 10, any value. X is the frequency, Y times. If X is equal to Y, means in R1 A occurring X time, in R2 A occurring Y time. Suppose R1, the current level of R1 is like 1, 1, 1, 1, 2. Here it is like 2, 1, 1. So if suppose if A is equal to 1, then we can say the X is equal to 2 here, because 1 occurring 2 times. Here also y occurring to a occurring means 1 occurring, y times means 2 times. So x is equal to y. So we can say both are equal. So we can say for 1, this is after removing 1 we can say 1 are match. So my array is, or my level is till now follow the property of anagrams. Now we have to check for 2, similarly for 2 as well. Now suppose here two more condition can arise, x greater than y. Suppose it is like 1, 1, 1, 2, or suppose it is like y greater than x. Suppose it is like 1, 1, 1. Okay, so here 1 occurring 1, 2, 3, 4, 5 times, here 3 times, so y greater than x. In both of these condition my string cannot be an anagram. Why? Because they x and y are not occurring the same number of times. So I can say there is at least some difference in frequency. So R1 value of current level cannot match to R2 value of current level. So we can say each level are not anagrams. So I have to return 0. I have to return here what is answer? I have to return 0. Okay, like here I can see here 2, 3 match. Here it is 2, 3. Here it is 2, 4. So for 2 I can say here 2 occurring one time, 2 occurring one time. For 2 it is follow the property of anagram. But for 3, here 3 occurring one times in this tree, at this level 3 occurring 0 number of times. So here 3 one time, here 0 times. So we can say this level is not anagram because 3 occur here but not here. Okay, so we have to return 0. Okay guys, so what we can do, so you can see we have to maintain the frequency of character. So what we will do, we will take a map for all the values in R1 for a R1 I will increase the frequency, now for all the number in my R2 I will decrease the frequency. Okay, now in here too, for each number a there are three conditions because the value is same. R1 and R2 is level different. If x is equal to y, then this condition work for x time, this condition work for y times. If x is equal to y, so how many times I am increasing? I am decreasing same number of times. So a map of that particular a will be become 0. Like here, suppose if we have 1, 1, 2 and 2, 1, 1. then this condition will run for 1 and 2 times. This minus condition will gonna run for 1 and 2 times. So increment 2 times, decrement 2 times. So after all, it will become 0. Now if x greater than 0 means plus plus condition will run more than y times. So means ma will have some positive value. Ma will have some positive value. Either if y greater than x means the number of times a character occurring r2 is greater than of r1, then minus condition will go not to work. So my map final value will be negative. In both of this condition, I can say in both of this condition, my tree will not follow the property of anagrams. So I can say if for a particular value a, my map value does not is equal to 0, either it is positive or it is negative, then it cannot be an anagram. For to be an anagram, all the ath value, like for 1, for 2, like here for 1 in current level, then for 2 and 3 in current level, for 5 and 4 in current level, for all the values like 1, 3, 2, 2, 3, the ordering does not matter. 5, 4, 4, 5, the map of value of 1, 2, 3 for any eighth value should be is equal to 0 at all level. If it is not, then we have to return 0, and if it is yes, if it all values is equal to 0, then at last we have to return 1. Okay, this is very simple approach. Now we know we will gonna to use q. Now how we will use bfs? I will take 2q. This is q1, this is q2. Okay guys, now q1 will store the current value, the first level value of my r1. R1. Q2 will gonna to store the first level value of my R2. Now I will take a map and handle all the values increase, decrease. Now guys, how I will traverse? Like I will take a variable s and put out size of Q1 in my s, size of Q1. Then I will gonna to run a loop like here. I will explain the code again. Last, don't worry. And for all the ith value till s means this is the current value, this is the current value of my level. So there is some value at level. I will take in current, remove the value from my queue, increase the data. Now if my current dot left exists means I have some value on its left side, I will gonna to push it in my queue. Similarly, if I have some right value, I will gonna to push it in my queue. Okay, so after doing completely s operation, my queue will contain the value of all value of second level, all value of second level. Okay guys, similarly I am gonna to done with q2 as well, but here the only difference is I will gonna to decrease, else while all problem are same. I will update my s to q2 dot size this time. Okay guys, but now after traversing all the levels, I have to traverse a loop till I have some value in my queue, means there are a level where some value exists in my root 1. There are some level whether there are some value in my queue, means current level exists in my root 2. Okay, after doing all of this, I have to check whether all level of root 1 should be covered and all level of r2 should be covered. Why? Suppose we are given a tree 1, 2, 3. Here suppose only one is given, so I can say one is match, one is match. Here q2 will become empty because q2 will become empty. Here q1 will contain this. So my this condition q1 dot size is equal to 2 means the q1 dot size greater than 0 will gives me true answer. Yes, size is greater than 0, but q2 dot size greater than 0 will false because its size will become 0 now, because it does not have any node, it have only single node on upper level. This is level 1, level 2. In level 2 it will q1 size will be is equal to 2, that is greater than 0 condition satisfy, greater than 0 condition false. So I am gonna out of the loop, I out of the while loop now. But I can say my tree are not satisfy the property of anagram because 2 3 does not have any competitor, or I cannot match 2 or 3 in my 5 to tree because I does not have any node. So I have to write a condition my both of queues should be empty, means I have traversed all the level of the both queues. If this is, then it means I my own level follow the property of anagrams, because I already check my map in each level that if I dot second is not is equal to 0 means the frequency of ath value all at all level is not is equal to 0 means they are this level is not follow the property of anagrams, then just return 0. Okay, this is what I am gonna to do. So how I am doing it, I am taken a queue of node star type, means that will pointer to my node q1 and q2. Initially they both contain root node, while their size is greater than 0. I am taken a map s1, s will denote the q1 size. Then this I have already explained. Then this I already explained. This is for checking that all value follow the anagram property. If any count is not is equal to 0, greater or less, it means x is not is equal to y. This x is not is equal to y, so I need to return 0. Okay, else by after completion of the loop I need to check whether all the level are of both root are complete or not. To overcome these type of condition, these where there are some level left but all level of secondary is complete. So guys, we can see, we can see all the test cases, 354 test cases pass out. I hope you all understand the problem. This is a hard problem, and the time complexity is we are gonna to traverse all the loops, all the nodes at most one time. We are accessing it one times, inside it one times. So all the nodes, suppose n is the number of nodes in my first queue, m is the number of nodes in my second queue. So I am gonna to access all the node at most one time. So it is n plus m, and I am also increase and decrease their frequency count in map. That will log n plus m operation. So it is log k operation, where log k is the number of different node in my current level, because map will contain, suppose this 111 occurring on one level, 111 occurring on other level in R2 as well. These both are anagram. Then my map will contain only single value, that is 1, because they both are same. Okay, so map does not contain three different value for three different one. It will contain just a single value. It will just decrease and increase the frequency according to R1, R2. Okay guys, so we can say it is equal to n plus m into some log factor log k, because for each node it will gonna to traverse, I am gonna to traverse in my map as well. Okay, so log k count it can be, you can say. So this is n plus m log k is the time complexity of the problem. So guys, I hope you will understand the problem, understand the time complexity as well, memory complexity. We are just gonna to take a node and a map. So we can say the maximum is just log k. Log k is the maximum number of node at my current level. Maximum number of node, because in my queue as well, if I am inserting some number of nodes, then I am removing as well. So maximum number of nodes will gonna be stored at a particular level when my current level node are the maximum. Like suppose it contains some n node, small n node, it contains m node. This is the maximum. If n plus n1 is maximum, means this is the total time, this is a total memory I am needing for a particular level. Okay, and for map as well, n plus n or log k. Okay guys, so memory complexity is also linear, what I want to say. Okay, so I hope you all understand the problem. If you have any doubt, then just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and check out my channel for more these type of videos. Thank you for watching this guys. Stay tuned.